Alrighty, everybody, exponential and logarithmic properties, or inequalities rather. So I've got up here an exponential inequality. And you'll get why I'm saying this in a second, but these do not have any type of restriction on them. Okay, so we can just start solving this as if this was an equal sign. And so this one we would just have to subtract 3 from both sides. Now, you can solve equations or inequalities one of 2 ways if it's exponential. You can either convert it into a log, or if we could get the bases to be the same here. Right, so I want to write both as a base of 2. We know that 8 is 2 to the third. And so now, just like when there's an equal sign, I get rid of the bases and set the exponents equal. Now I'm going to say x minus 1 must be greater than 3, and I'm just getting rid of the 2's here. All right, that tells us x must be greater than 4. That's all we'd have to do on this one right here. All right, so exponential inequality is pretty easy. Logarithmic inequality is not so much. Before we start the question, we have to think through, is there anything that is outside of our domain? In other words, is there any number I cannot plug in for x here? Well, to figure that out, we take the insides of the logs. So x minus 4 and 3x plus 4. There's no x on this one, so we can ignore that one. But we're going to make them positive. Whatever's inside the log must always be positive. All right, so here we're going to add 4. X is always greater than 4. So I'm going to put 4 wherever I want on my number line. Okay, I'm going to put it right here. And I'm going to shade to the right of 4. So not including 4. I'm going to shade over here. So my answer must be in this part. Okay? We're all going to do the same thing with 3x plus 4 now. So we're going to subtract 4 and divide by 3. X must be greater than negative 4 over 3. But if I shade that, so let me put, so a negative number is to the right of a positive number. And let's go with green here. If I was going to shade to the right, I haven't excluded anything additional, right? Because it's going to be the overlap that ends up being our answer. So our answer still has to be that something over here. We don't know the exact interval yet. That's what we're going to look to find here. All right. So just like if it was an equal sign, we want to have one log on a side. And so we're going to use our property that if we're adding logs, we can multiply the insides. So I'm going to distribute the 2 to the x minus 4 and make it log of 2x minus 8 is less than or equal to log of 3x plus 4. Now, just like with exponents, if we have the same log on both sides, or the same base log on both sides, we can get rid of the logs and make 2x minus 8 less than or equal to 3x plus 4. All we have to do now is subtract the 2x. Subtract the 4, and this says x is greater than or equal to negative 12. All right, remember, if you forget which way this is, it helps if x is on the left. We flip everything. And so this is pointed to the right, so we're going to shade to the right of negative 12 here. So negative 12 would be way over here. I'm just going to put it right here. Negative 12, we're going to shade to the right. And so our answer is just the overlap of these 3. So the only part that ended up with all 3 is this portion in here. So our answer is actually x is greater than 4. Now, it's not always just a restriction from the beginning, but we have to consider this as we're going through it, okay? So let me look at one more. This one is set up already, but we only have one log in the problem. And so the only way we can solve a log equation or a log inequality is to then convert it into exponential form. And so we're going to keep the base. The base is 2. The other 2 things are going to switch sides. So it becomes 2 to the third. And on the right, we're going to have x plus 6. But because x switched sides, the less than is also going to flip to a greater than. If we cube the 2, we get 8. So 8 is greater than x plus 6. Subtract the 6. 2 is greater than x, or again, x is less than 2. Now, before I, again, just circle this, I did forget at the beginning, we have to take the inside here. Take the inside. It has to be positive. So x plus 6 must be greater than 0. We're going to subtract 6. X must be greater than negative 6. So if this is negative 6, all right, me shade to the right of negative 6. We're also now going to shade, because we got for our answer x is less than 2. So 2 is to the right of negative 6. So I am going to shade when x is less than 2. So that would be this way. Right? And the only overlap is this section in here. So this is our answer. It's the interval from negative 6 to 2. So negative 6 is less than x is less than 2. All right, so again, that would be the interval that we get from this question right here. All right, that's it, guys. Stay flawless.